All right, this problem is the real challenger problem. I'm debating whether or not I would require you to do these or not, but I'm going to go through this example. It's really a great algebra example, okay, of how you convert a repeating decimal to a fraction, okay? So this is 0.6 repeating, okay? 0.6 repeating, you should know what that is as a fraction. This is one you're supposed to know. 0.6 repeating is 2/3, okay? We'll talk about these in a second. But 0.6 repeating as, where did those slides go anyway? I was supposed to talk about them. 0.6 repeating is not 6/10, right? That would just be 0.6 is 6/10. So it's sixes that go on forever, and I can't just write it over, I can't use place value. So the way you figure this out is with an algebraic process here that looks like this. You set n equal to this repeating decimal. Then you multiply both sides of this equation by what we call the magic number. The magic number is 10, is a factor of 10 for every digit that is repeating. Okay, since there's one digit repeating in this repeating decimal, we'll multiply by 10. If there were two digits repeating, we would multiply by 100. I'll show you an example in a second. When I do that, I get 10 times n on this side, and over here, multiplying this by 10 moves the decimal place, 1 point, and so now you get 6.6666666. So 6.6 repeating. Now I can subtract n off from both sides of this equation. Okay, that's what algebra does, do the same thing to both sides. So subtract n off of this side, I get 9 n's. And subtract n off of this side, well, n and 0.6 repeating are the same, so that gets rid of all this repeating decimal stuff, which is what I need to do, right? So the repeating decimal part is gone now, and 9 times n equals 6. Now I can solve this one-step multiplication equation by dividing both sides by 9, and then I simplify my answer of 6/9, and I get 2/3, okay? So this process can be pretty confusing, right? Regular 8th grade math people, this is an 8th grade math topic. Regular 8th grade math students die with this particular problem, okay? They really don't do well with it at all. Sometimes we delete it and don't make them do it at all. We just like, it's too hard, we're skipping it this year, okay? I'm probably going to do it for you guys too, but I'm going through the demonstration here just because advanced math students kind of sometimes really ought to be getting what's happening here. Okay, so this is an example of a 2-digit repeating one. I'll just show you how this one works. Okay, so 2.18 repeating, what is that as a fraction? It's not 1800ths because there's a repeating bar here, which means 181818181818. So we set n equal to that. What am I going to multiply both sides by in this problem? Nick? Not 2. Not 10, because there's 2 digits repeating. 100. Okay, I'm going to multiply by 100 so that the decimal point will move 2 places to the right. That's what happens when I multiply by 100. Okay, so 2 digits are repeating. I multiply by 100, both sides. Okay. And that makes this do this, right? So that, I just don't get it. The decimal point moves 2 places, and I get 18.18181818 equals 100n. Now subtract n from both sides, okay? And n, which is the same as 0.18 repeating, lets me get rid of this repeating part. And I'm left with 99 n's equals 18, which I can then divide both sides by 99 and get my answer. That's the fraction, 18 99s, which you'd recognize are both divisible by 18 and 99 are both divisible by 9, okay? Not 99, oh, right, divide both sides by 99. And then both sides divisible by 9, so that's 2 over 11. And then don't forget to put the 2 in the front, okay? So this is not something that I'm going to require you to do, okay? But I really wanted to expose it to you because some people think this is cool. Some advanced math people groove on this stuff, right? I think it's cool. I will tell you the shortcut here. 0.18 repeating, you can go right to this step right here. Every time it's gonna work out the same way, right? So 0.23 repeating is 23 over 99. 0.72 repeating, 72 over 99, and then you can simplify it. Okay, so it always works that way. Because I subtracted from 100n here, I subtracted n from both sides. This side I subtracted an n, which left me with 99 n's. And over here, it's n and 0.18 repeating are the same thing. So this side I subtracted by the repeating decimal to get just 18.
Right, so that means n is the repeating decimal?
Correct, that's what I said at the beginning, right? I let n equal the repeating decimal at the very beginning. That's how I start these.
Oh.
Yep. Okay?
But then wouldn't it be 99.9?
I vaguely understand.
Nope.
Mm-hmm. Yes. I
Yes.
vaguely understand.
And doing 0.18, if you memorize your tables, then you can do that in your head because 0.09 is, like every 0.09 repeating is 1 out of 11.
Is an 11. Yep, we'll see that in a second here because, so I'm going to skip this one. There's a dot in there of 0.42. Well, we can go right to the answer though, what we just talked about. 0.42 repeating is 42 over 99. Okay, so you could just kind of skip right to that if you wanted to. Come on. But
Is this gonna be an ongoing drama throughout the year?
yeah, it's just the electrons that don't participate very well. So 42 over 99, then you can see if it simplifies, and both of these are divisible by 3. Anyone know what the divisibility trick is to check if something is divisible by 3? How do I know 42 is divisible by 3? Anyone know the trick, Luke?
Well, 30 is 30 times 10 times 3, and then 12 is.
Okay, that's true, but how about 396? Is that divisible by 3? Yeah, how do you know?
If all of the digits are, oh wait.
It has something to do with all the digits.
With that one, all the digits are divisible by 3.
That's true. Okay, how about 276?
They're all divided by
276.
divisible by 6.
726. Divisible by 3 or not? Come on, you pick a bracket. Okay, is 726 divisible by 3? The answer is yes. The trick is,
Oh, you add all of them together.
correct, Luke, and then if you add all these together and the result, the sum is divisible by 3, then the big number is divisible
I
by
didn't
3.
realize that until you wrote down.
Yeah, so this is 7 plus 2 is 9, plus 6 is 15. 15 is divisible by 3, that means 726 is divisible by 3. Okay, that's the only other rule I remember, because otherwise, divisibility rules, numbers are divisible by 2 if they're both even. Numbers are divisible by 5 if they end in 5 or 0.
Divisible by 2 is if the last digit is even.
Even, right, the last digit is even, they're divisible by 2. Okay, and divisible by 3, if you add up the digits and the sum is divisible by 3, then the original number is divisible by 3. There's other rules for other ones. I don't know any of them. I don't memorize any of them. I think it's a waste of brain space. As long as I can remember 2, 3, 5, and 10.
Isn't there a similar rule for 9?